are you, my friends? In this video, I would like to present 7 different methods to solve linear systems. In this video, I will take one example, 2 by 2 linear system, and apply the 7 different methods. And after that, you can apply that to any linear system, 3 by 3, 4 by 4, etc. Just a few seconds, I would like to define a linear system. System of equations is a set 2 or more equations considered together. So we can have 3 equations, 2 equations, 4 equations, 5 equations, and we have so many variables. This system here that we see, 7x plus 6y is equal minus 3, 3x minus 2y is equal minus 18. This is a 2 by 2 linear system in 2 variables. As we can see here, if we graph the first equation, which is a straight line, we graph the second equation, which is a straight line, then the point of intersection is 3 minus 4. So the solutions are the intersection points of the graphs. If there is no intersection, there is no solution. Here I'm listing the 7 different methods just by name. Method number 1, elimination method. Maybe you have seen it, you know it. Second method is substitution method. These are easy methods. I said here easiest if this is 2 by 2. If you have 3 by 3, 4 by 4, 5 by 5, there are better methods. Method number 3 I will consider here is graphing method. Method number 4 is Gaussian elimination method. This is a method created by Gauss, a German mathematician. Method number 5 is Gauss-Jordan elimination method. There's some adjustment on method number 4. This is the best method we can see, Gauss-Jordan elimination method. And then method number 6 will be matrix inverse. We find the inverse of a matrix. Method number 7 is Cramer's rule by using determinants. You can go back, if you don't know what is determinant, in another video to see the determinants of a matrices. Let's start. Now this is the question we will consider. 3 over 4x minus 2 over 3y is equal to 5, minus 1 over 3x plus 2 over 9y is equal minus 2. This is a linear system in 2 variables, x and y. So I will consider this example. You can pause a little, please, and try method number 1 maybe. You can try method number 2 if you like. Before we start, there is something nice here you should know. When you have any equation or system of equations, linear or non-linear, with fractions, this is a nice idea here. Since the linear system contains fractions, so we can remove the fractions by the least common denominator, LCD. You can do the question with fractions, no problem like this. You can use any method you like. You can deal with the fractions, but it's better, recommended, that here we find the LCD 12, 3 and 4. So multiply both sides by 12. Remember, don't forget to multiply the 5. So 5 times 12 will be 60 on this side. So 12 times 3 over 4 will be 9x. 12 times 2 over 3y will be minus 8y is equal 60. This is equation number 1 now. You can see there is no fraction. Same thing for equation number 2. In the fraction here, we see in the denominators 3 and 9, so we can multiply by 9 to remove the fractions. The LCD is 9. So we get minus 3x plus 2y is equal minus 18. This is equation number 2. So now we can take this system here, equation 1 and 2, and apply the 7 methods. Method number 1, elimination method. Here I put 4 steps. I wrote them in case you need to go in details and understand the method. You can read it anytime you like. I will explain it so quickly here. Elimination means we will eliminate. You see the verb eliminate, cancel or delete or get rid of one variable. You can see here, eliminate one variable. So you have to decide. You have to tell yourself, I like to cancel the X, or I like to cancel or delete or eliminate the Y. Then you multiply up and down by numbers so that you will have two numbers opposite in sign. It's better to explain by example, and then you can come back and read the steps. This is the whole solution here, one slide. So this is method number one. We have the same system that I mentioned at the beginning. 9x minus 8y is equal 60, minus 3x plus 2y is equal minus 18. So this method number one, M1, elimination method. See, I decided in this question, as you can see here, this is the given, I decided to cancel the y, the x. See, 9x I have already there. What will make here minus 9x? The opposite. So already we have minus 3. So I multiply equation 2 by 3. The whole equation. See, this is the whole equation. Minus 3x plus 2y is equal minus 18. Multiply the whole equation by 3. So I get minus 9x plus 6y is equal minus 54. And then we add the two equations to cancel the x. If we cancel here the x, 0x, minus 8y plus 6y will be minus 2y. 60 minus 54 is 6. Divide by minus 2, y will be minus 3. We found y. So we canceled x, found y. Now, on the other side, you have to find x. Use any equation you like. Use usually the easiest. So the easiest here, equation 2. I replace y by minus 3, then I get x4. Now I have to write the solution as 1.4 comma minus 3. This is the point of intersection of the two straight lines. These are two straight lines now. This linear system consists of two straight lines. Let's see method number 2. Now, same system we will consider. Method number 2 is substitution. So we take one equation, anyone, you substitute in the other. Again, you take equation 1, substitute in 2, or you take equation 2, you substitute in 1. It's up to you. Take the easiest method you like. So I said here, step number 1, choose any equation, either 1 or 2. After that, you solve for x or solve for y, and call the new equation star. Just to make things easy, call this one star. Now you substitute star in the equation you did not use, and then you find the variable. Let's see the solution here. Same system, 9x minus 8y is equal 60, minus 3x plus 2y is equal minus 18. Substitution method, M2, method number 2. I will choose here equation 2. It looks easier. Solve for y. So in equation 2 here, you can see I leave the y here, 2y, take minus 3x on the other side, and then divide by 2. So this is what I get. Y equals 3x minus 18 over 2. I call this star, equation star. You can call it equation A, equation B, equation C, equation 3. It's up to you. I call it star. Now, I substitute star in equation 1. You see here in equation 1, 9x minus 8 in the bracket. I put the value for star, which is y here, equals 60. Now 8 divided by 2 is 4, so there's no fraction here. And then we distribute 4 times 3x minus 12, minus 4 times minus 18 plus 72. Solve for x. X will be 4. See, this method is nice, substitution, because when you find one variable, you go back to star. See, always in the substitution, if you find x, go back to star. If you find y, go back to star. So we need y now in the star, 3 times 4 minus 18 over 2. So y will be minus 3. So this is the solution. Always the solution will be x and y. We call this ordered pair. Ordered pair means the first number is the x value. The second number is the y value. Okay, before we proceed, please, you can take the same system now here, this one, linear system, equation 1 and 2. You can draw it because now method number 3 is by graphing. It will take time to graph, you know, straight line, find 2 points or more than 2 points if you like. 2 points are enough. So it will take time to graph it, but I will show you the whole solution. So this is the graphing method. Graphing method is very nice. When the system is difficult and you cannot solve, you can graph it and find how many solutions by counting the points of intersection. 2 points of intersection means 2 solutions. 3 points in the intersection, 3 solutions. 1 point, 1 solution. No intersection, no solution. Okay, so what do we do here? Simply, we graph equation 1, we graph equation 2, and then we look for the intersection. It looks here very nice colors here, I think. So I get here 9x minus 8y is equal 60. This is M3 graphing method. Minus 3x plus 2y is equal minus 18. I take equation 1 and then I find 2 points. If I replace here x by minus 4 in the x here, minus 4, solve for y, y will be minus 12. So minus 4 minus 12. So that's a point here. If I put x 12, you can take any number here because domain and range are all real numbers. So you can take any number. Sometimes there are fractions. But I try to put here integer numbers, easy numbers. Put x 12, solve here for y, y will be 6. 12 and 6 is there. See these 2 yellow points? You draw the line, the blue. The blue line, equation 1 with the yellow points. Now equation 2 is the red one with pink points. And now the points of intersection is 4 minus 3 as we expected. Now, no, it's not easy to graph and find the solution directly because you need accurate. This is computer graphing. You need accurate. But still, this is a method we can consider. If you have a difficult system, as I mentioned, you graph it, at least we know how many solutions we have. All right. Now let's move to method number 4. One of the best methods, Gaussian elimination with back substitution method. Long name. The name is Gaussian from the person called Gauss, German mathematician. He used matrices, he used elimination, he used substitution in the method. But this is the name of the method. Gaussian elimination with back substitution. Now it looks long, this method, it looks long, but it is not long. Especially if we have 3 by 3, it's better to use it. Now first we write something called augmented matrix. I will show what does it mean on the next slide. And then we have to change the rows and columns until we get ones in the main diagonal. You know, 1, 1, 1 in the main diagonal of the matrix. And then zeros under the main diagonal. We call this row echelon form. And then we find a solution. Let me explain by the example. Before I start, if we are using method number 4, Gaussian elimination with back substitution, we should have an aim. If it is 2 by 2, very clear aim here. We should have 1, 1 in the main diagonal. We call this main diagonal, and 0 under the main diagonal. If it is 3 by 3, we have same idea. 1 in the main diagonal. You see 1, 1, 1. Zeros under the main diagonal. We should have zeros. We don't care about the other numbers. And so on. So on means if we have 4 by 4, 5 by 5, 6 by 6, 10 by 10, 50 by 50. You make ones on the main diagonal and zeros under the main diagonal. But the way you have to go, these are the steps. See number 1 here, number 2, number 3. These are the steps. In sequence you should go. Like change the first number here to 1. Change this number 0. Change this number to 1. In order. This one, the steps are 1, 2, 3. Then we go to 1, 4, and 5. Then we go to 6. So here there are 6 steps. Now let's see the same system, same example we have started, but now by using method number 4, Gaussian elimination method. Now first we write the augmented matrix. What I mean by augmented matrix, I take only the coefficients and the constant numbers on the right side. So first, you have to rearrange the system. You see the x here line up together, the y's, they line up together, the constant on the other side. In Gauss, the system should be arranged. It's not like other methods because it should be arranged, the x's, y's, and the constants. Then I write them here. In this matrix, I call it augmented. Augmented means big matrix enlarged. So we have 9 minus 3, as you can see, minus 8, 2, 60, minus 18. Now remember the aim. Remember the aim. The first number here should be 1. See, as you can see here, the first number here should be 1. So to make it 1, we can divide by 9. But since I see 9 minus 860, I will have very big fractions, big numbers in fractions, so I can avoid that. I can interchange the rows. Also, you can learn that you can interchange the rows. So I take row 2, which is minus 3, 2, minus 18, in row 1 up. And then I take row 1 in row 2. That's easier. Now, minus 3, I needed 1 according to Gauss aim. You can see that in the previous slide. So divide by minus 3, all row 1. So it becomes 1 minus 2 over 3, 6. You have to do this more than one time, please, because this method, it has many numbers and it needs time to practice on it. And then you will be a little faster after that. Now, after the 1 here, I look at the 9. See this 9 here? I have to make it 0. How do I make the 9 0? I add to the 9 another minus 9. How? I take copy of row 1. See, this is row 1, stays the same, row 1. 1 minus 2 over 3, 6. I multiply by minus 9. From where I get minus 9? From the 9 there. If it is 7, I multiply by minus 7. If it is minus 6, I multiply by 6. Just take the opposite and multiply row 1. Then add to row 2. Now you can find another video on Gauss method in details if you want to learn more, 2 by 2, 3 by 3, and many examples. But here in this video, I'm stressing the idea that we can do linear systems, one example in 7 different methods. That's the aim of this video. So let's multiply now. Minus 9 times this one. Add to this, you get 0. Minus 9 times minus 2 over 3. Just do it on your paper. You will get 6. Add to minus 8 down, you get minus 2. Minus 9 times 6 minus 54. add to 60, you get 6 also. So after this step, I need to change this number minus 2. You see this number here? It should be 1 because I need, in the aim, I need 1s on the main diagonal. So divide by minus 2, divide by minus 2, only row 2. So I get 0, 1, minus 3. So look at this equation here. 0x plus 1y is equal minus 3. So y will be minus 3. Now, in the Gauss method, we have back substitution. So I take row 1 here, I write it here, x minus 2 over 3 times the y, which is minus 3, is equal to 6. So x will be 4. So I get the solution 4 minus 3. This is method number 4. Now, method number 5, very similar to method number 4. There's little change, little adjustment on the Gauss method. That's why we call it Gauss-Jordan, another mathematician. He made some adjustments on Gauss method, and they called it method number 5. I called it method number 5. In method number 5, I can put here a note at the end, there is no need for back substitution. So we continue the same question in the same matrices to find x and y. I myself prefer method 5 than method 4. Now just remember the aim here. It's very similar, very close to the Gauss's aims. In 2 by 2, I need 1, 0, 1, 0. You see, in the main diagonal, I need 1s here. In the main diagonal, I need 1s. Other numbers are zeros. Also, 3 by 3. I need 1, 1, 1 on the main diagonal. Other numbers should be zeros. In 4 by 4, same. I need 1s on the main diagonal only. 5 by 5, 6 by 6, 7 by 7. But remember, you have to go in sequence or in order. So, in Gauss, you do 1, 2, 3, then you continue Gauss-Jordan to step number 4. You make it 0. You cannot go the other way around. So it should go 1, 2, 3. 1 down, 0, to the right, 3, up, make it 0. I put all the steps here you need. These numbers, 1, 2, 3, 4 are the steps. Also here, 1, 2, 3, 4, 5, 6. Then 7, 8, 9. Let's apply this in 2 by 2. Gauss-Jordan, method number 5. 9x minus 8y. See, I write also augmented, same way as Gauss. You can say 75% almost the same. So I can start the same, first line is the same, change number 1 is the same, change the 9 to 0 is the same, change minus 2 to 1 is the same. You see, we stopped here in Gauss. We stopped here. We stopped here. You see this one? In Gauss-Jordan, we continue one more step in 2 by 2 to make it 1 on the main diagonal. So what do I do here? Minus 2 over 3 I have up. I have to make it 0. So multiply row 2 by 2 over 3. Then add to row 1. So I get 1, 0, 1, 0. So when you multiply 2 over 3 times minus 3, that's minus 2. Add to 6, you get 4. See, directly now in this method, this is the best method I prefer. X directly will be 4. Y directly will be minus 3. So you don't have to do back substitution. You don't have to do equations. You don't have to use X and Y. You don't have to graph. In my opinion, this is one of the best methods. Maybe method number 7 also is good, but I prefer method number 5. You'll see method number 7 after a few minutes. Okay, now method number 6. We're almost there. Method number 6, we use the inverse of the matrix. So we take the system 2 by 2, 3 by 3, we can do that, 4 by 4, 5 by 5, and then we have to make something called coefficient matrix. So we changed the whole system into equations, AX equals B. But remember, these are matrices. A is a matrix, B is a matrix, X is a matrix. And we cannot divide matrices, but we can find the inverse. So if you have AX, you see, if you have here AX equals B, directly you can write X equals A inverse B. You cannot write B over A because these are not numbers. These are matrices. I will show you on the next slide, before method number 6, how did we reach from this AX equals B to this X equals A inverse B. One slide. This is the proof. If you have the system AX is equal to B like this, I need X. So multiply A inverse on the left side here. See, A inverse, A inverse. I have A inverse AX, A inverse B. Just multiply on the left side of this equation by A inverse. I know, and you should know also, A inverse times A is I. That's the identity. If you multiply any matrix by the inverse or the inverse by the matrix itself, you should get I, identity matrix. Identity matrix times any matrix is the matrix itself. So I times X is X. So from AX equals B, directly you can write, see this pen here? If you have AX equals B, directly you can go X equal A inverse B. We will apply this to method number 6 to our example. Also, before the example, I put one extra slide here as a gift. If you have 2 by 2 only, there is a quick method, there's a formula to find the inverse. 3 by 3, there is no formula. It will take time. You can see another video on how to find the inverse of matrices 3 by 3 or 4 by 4. Now let me explain this very quickly. If you have a matrix A, B, C, D, but remember it should be 2 by 2, A, B, C, D. Directly, just one line, you can find A inverse. 1 over, you have to remember this carefully, 1 over AD minus BC, and then switch the main diagonal. You see, we have AD, this is given, it becomes DA. Switch it, the main diagonal. Remember, switch the main diagonal. Multiply the other diagonal by -1 and leave the numbers. B becomes minus B, C becomes minus C. This is a formula, guys. This is a formula. You can directly apply it when you have a 2 by 2 matrix and you need the inverse. Now it's very clear that if this number here, AD minus BC, that's a number, we call it determinant. If this number is 0, there is no inverse for A. Now let's take a simple example here, only about the inverse, before we go back to method number 6. If this is A, -4, -7, 2, 5, you see that? If I need the inverse, one line, but you have to be careful. 1 over AD minus 4 times 5 minus 20 minus -7 times 2. See, this is the number here, minus 20 plus 14. And then I switch the main diagonal here, 5 up minus 4, and the other I multiply with -1. So it becomes 7 minus 2. Then I have to multiply this scalar, 1 over minus 20 plus 14, 1 over minus 6, multiply by every element in the matrix. So this is the inverse now. See, the inverse here is this one. Minus 5 over 6, minus 7 over 6, 1 over 3, 2 over 3. All right, let's go back and continue here. Method number 6. I have the same system here. The system that we started from the first slide. It was fraction, remember? It was fraction. We multiplied each equation by the LCD, least common denominator. to remove the fractions. Now, let's go back here, please. Concentrate on method number 6, matrix inverse. I write only the coefficient here, 9 minus 8 minus 3 and 2. See, I don't write the augmented. Remember, in method number 4, method number 5, we write augmented. Method number 6, we write coefficient. I wrote it here for you. A is called coefficient matrix. Only we are using the coefficients after we rearrange the system. So A is the coefficient matrix times the X is equal to B. B is 60 minus 18. This is only the B. So I need the A inverse now. See, I said here, find the inverse of A, then multiply by B, as I showed you in the previous slide. So the whole idea now, take A, 9 minus 8 minus 3, 2, find the inverse on the next slide, and multiply by B to get the solution of the linear system. This is the formula from last slide. We have A 9 minus 8 minus 3, 2. And then A inverse, this, I wrote the formula here in yellow. You can use it if you did not memorize it. A inverse will be minus 1 over 3, minus 4 over 3, minus half, minus 3 over 2. Multiply this A inverse by B, which is the 60 minus 18. You know, when you multiply matrices, you multiply row by column, row by column. Remember that. If you need more help, you can find another video on multiplying matrices, and there are many, many, many examples there. So this is row 1. You see, this is row 1 multiplied by column 1, which I mean minus 1 over 3 times 60. And then you add minus 4 over 3 times minus 18. You get 4. Same thing. Take row 2 here, row 2. Minus half times 60. And then you add minus 3 over 2 times minus 18. You get minus 3. So the solution will be 4 is the X, Y is minus 3. The same solution as expected in the 6 methods. Now we still have one method, Cramer's rule. Method number 7. This is a Swiss mathematician, 1704 to 1752, Gabriel Cramer. Cramer invented a method which is also nice. He uses determinants, not the inverse, not augmented. This is the rule here. This is rule number 7. Some people, they like it. I like it second, actually, after method number 5. So we have a system here, A1x, B1y is equal to C1. These are numbers. A1, B1, C1 are numbers. A2x, B2y is equal to C2. Remember, these are coefficients, constant real numbers. Now, to find x directly, see in Cramer's rule, directly we go to the x, directly we go to the y. So what do? We find dx over d. So this is determinant, but you have to remember, you have to be careful which determinant to use. If you are finding x, you take C1, C2, after you rearrange it, you put it in the first column. Then you write B1, B2. Now, in x and y, we have the same denominator, which is the coefficient, but we find the determinant here. You know, determinant are 2 bars. It will be a real number. It is not matrix. Also, you can go to another video on determinants, and you can find all the rules there and many, many examples. So, back here, in x and y, both denominators are the same number here. See A1, A2, B1, B2, A1, A2, B1, B2. So when you find one, you can use it in the other. But in the numerator, the numbers are different. When you find x, you put C1, C2 at the beginning here in column 1. If you need y, you put C1, C2 in column 2. You leave A1, A2. Just Just you have to remember the formula. This is 2 by 2. 3 by 3 is the same, 4 by 4, 5 by 5, but it will be longer. Let's take our nice example. 9x minus 8y is equal 60, minus 3x plus 2y is equal minus 18. We expect the same answer. You see, directly here we go to x. We know x is 4, you know, y is minus 3. Let's see how by Cramer's rule. D, let's go on the denominator, please. D is 9 minus 8 minus 3, 2. See, same number? So multiply the main diagonal, 18 minus 24. See, minus 6 in the denominators are the same. So you can find it one time. Let's go in the numerator. I put 60 minus 18 at the beginning, and then I multiply 60 times 2, 120, minus 144. So minus 24 over minus 6 is 4. You can do it another time, please, to review it. And here in the green spot, I put the formula for you. This is Cramer's rule. Formula for the x, formula in the blue for the y. Now, y is equal dy over d. I put C1, C2 in the column 2. So 9 times minus 18, 1 minus 162. 60 times minus 3 is plus 180. 18 over minus 6 is minus 3. So we know the solution will be 4 and minus 3. Now check the 7 methods, please. Learn them and see which method you can use in any exam or any place you like to use math. Now I will leave something nice for you. 3 questions as practice. But please listen carefully. How did I divide the questions? This is a new question. 3 over 4x, 1 over 3y is equal 1, 1 half x plus 2 over 3y is equal 0. Solve this linear system, please, by the first 2 methods. One time use elimination, one time use substitution. So do it by 2 ways. For sure, you will get the same answer. And I provided the answer for you at the end. Now, let's see. Practice number 2. I put another system here. Linear system, different numbers, different answer. Use the methods 4 and 5. See, I skipped method 3. So in practice 1, you can use method 1 and 2. Actually, you can use any method you like. In practice 2, I suggested that you can use method 4 and 5, Gauss and Gauss-Jordan. For sure, you will get the same answer. Now, method 3 is graphing because it will take time. I did not write it, but you can graph them if you like. Practice number 3, use method number 6 and 7. There is a little surprise here. The coefficients are all irrational numbers except the constants. You see square root of 2, square root of 5. It's not ugly. Medium nice numbers. You can try and then you find the solution. Only the answers here. Practice number 1, you see the answer. Practice number 2 by 2 methods. Practice number 3 is the solution. And I hope you enjoy it. Thank you for watching this video. I hope I can see you in another video with another topic. Thank you very much.